I want to go backwards. Okay. What do I mean by backwards? Okay. Yesterday we started with select files. Sensors, and I'm going to change the reference data set. Sorry, I'm just going to check. Hang on, give me 1 second. Yeah, I've chosen, let me just show what I've done. I've gone backwards on the tree. Okay? Nextclade. You always need to know where are you in the world of data. Okay? So the reference that I used yesterday, the closest reference in nextclade to what I had was B1. The start of the B1 clade over here. Okay? But now I wanted to see, and the thing is that my consensus, it only had one mutation compared to B1, remember? So I'm now going back, and I've chosen the start of clade 2B as my reference, okay? And if we see here, still 93% coverage, okay? Still that is looking the same. B1 lineage, 58 mutations. We see there's more mutations listed here, okay? Because I'm comparing against the older sequence, okay? This is more like what you will see when you've got a clade 1, because you're comparing against the older reference, right? So, what I wanted to discuss quickly this morning before handing over to Stanislas is how did we get to here, okay? This is a prettier version, thank you, Kirsty. This is a prettier version of what I drew on the whiteboard yesterday, the steps of the analysis, okay? Squirrel, we'll talk about squirrel later. We got the consensus, okay? Consensus, fast day, okay? I want to go one step back. Consensus is made by calling variance, okay? And when we call variance, using different tools to call variance, there is this slide. It is shared with you on the WhatsApp event. I think that
I'll share it again.
To share it again, please, Kirsty. If you don't need to take photos, okay? I just want to take it with me. But yeah, okay. The format that you store variance in is a format called variant call format, VCF. Okay. Now Windows gets a bit confused when it sees a file called VCF because Windows has another file type called VCF, which is for something called vcard. It's totally different to bioinformatics. So if you try and open a VCF file on Windows, it might open Outlook or something like that, unless you do what we're going to do this morning. Okay, so you must just. And VCF format is made by a variant caller. There are many variant callers: GATK, Freebase, IVAR. There are many tools that can be used. We use a thing called Freebase, but okay. And I'll show you how to see this yourselves in a minute. But this is what VCF looks like. Okay, let me just see if I can zoom. How do I zoom this thing? Control plus, Control Shift plus. There you go. Okay. This is VCF, okay? I will show you in your output. here's the output folder from when you did your 1-mpox sample, right? And we looked at the run all consensus yesterday. Now I'm looking at the call consensus freebase. Okay? That is the output of this step over here. It does two things at once. It calls the variance, it finds the variance, and it makes the new consensus. That's why it's called call consensus freebase. Okay? And if I look in this folder, then this is actually the same consensus file. If you had multiple samples, you'd have multiple files here, right? But I only had one sample, okay? Here's your fast day file, the consensus that we looked at just now. Here is a VCF file, variance, okay? Now, if I open that, I'm using a text editor to open that, okay? I'm using a text editor called VS Code, which mostly programmers use, okay? Anybody has heard of Visual Studio Code here? VS Code? Yes, Stephen, of course, I'm sure. Yeah? Yeah, yes. So this is, I will get you guys to install it just now, but you need a tool to open text files nicely. And VS Code is a good tool for that, okay? So I'm to say open with Visual Studio Code. And here is the file, okay? The first part of the file, where it has what we call a hash character in English. What do you call this character on Francais? Yes, okay. So when you got this is just information about how the program ran. It's like a log file in a way, okay? And there's all sorts of information that I'm going to ignore for now because I want to go past this and I want to look at this, okay? Here are my actual variants. It looks a little bit like that bed file I showed you on Monday, okay? Here is the name of the reference, okay? Reference, this is the one that is specific to clade 2 when you're using Yale primers, okay? This is a clade 2 reference, okay? MT903345. If you want to see that sequence, you can go look it up on NCBI or something like that, okay? Then it says CT and a whole pile of other things. What this is saying is that in the reference, it was a C, but the variant said there is a T here, okay? And it said that the position is 7793 in the genome, and then there's a whole lot of stuff over here. What I want you to look at is where it says, yeah, you want to, yeah, slow down. Okay. So, do you want to translate quickly?
Le fichier qu'il vous présente actuellement, c'est un fichier ce qu'on appelle le fichier des variants. Le fichier des variants bioinformatiques, on appelle le fichier VCF. Dans l'intérieur du fichier VCF, il y a l'entête. Toutes les lignes qui commencent par dire, c'est ce qu'on appelle l'entête. L'entête, ça va vous donner des informations sur comment le programme qui a appelé les variants, les étapes suivies par le programme qui a appelé les variants. Et après, où il n'y a pas de pièces, après ici, ce sont les lignes où on a les variants avec des informations sur les variants. Donc, il y a la colonne de chromosomes, la colonne de position, ID, référence, alternative, qualité, ainsi de suite. Donc, si on regarde ce chromosome, ça veut dire que ici, par exemple, si on a un organisme multichromosomique, on a là votre chromosome 1, chromosome 2, comme c'est un organisme monochromosomique, on met le nom du génome de référence. Donc, position, c'est à cette position-là, sur la référence, c'est un C, et sur notre génome,
Is that yours?
Oh, there's no, it went dark. The brightness is down. Because I can still see it, but it's dim.
Then you can read Chinese.
So we try switch off, switch on. Oh, there. Okay, switch off. Oh, oops. Just give it a second, maybe it's better there.
Yes.
Okay.
Donc, à cette position, la position 77-93, sur la référence, on avait un C, et sur notre génome, c'est-à-dire notre génome consensus, on a eu à cette position-là un T. Et donc, tout ce qui est listé là, ça nous donne des mutations qui sont apparues. Et les autres, ce sont des informations relatives à la mutation qui a été obtenue.
Okay. Next part of the explanation. Then we have quality. Okay. And here, the big number is good. Okay. So 6,492, it's good. 4 is very small. Okay. Now, I want to highlight this thing, AF, okay, allele fraction, okay. So remember in the picture that there's many reads that are mapping to this position, okay. I'm just going to scroll a bit sideways so you can see something else. Yeah. Depth is depth of reads, okay. How many reads are at this position? 200. DP is depth, okay? AF is 1. That means AF is a number between 0 and 1, okay? 1 means, you can say 0, you can think of it, it's a fraction, but you can think of it like a percentage, right? So AF of 1 means all of the reads are saying it is a T. If half of the reads said it was a T, AF would be 0.5 because half of the reads, okay? And then over here, there's a variant called, but depth here is 84, much lower depth, and AF is 0. So almost no of the reads. It's obviously rounding it to, but maybe it was 1 read or something like that. Almost none of the reads are supporting this variant over here. This one where it goes from a T to an A. Okay, so that is when we make the consensus, we put the good variants in and not the bad ones, right? So we put the AF, high AF. I think we said 75% yesterday, or 80% or something like that. I'm going to try and see if there's any AFs that are like in between. AFs, these are all 1s, 0s. I think this has been normalized. Okay, then just one last other type of thing. These are single nucleotide variants. One nucleotide is changing from one nucleotide to the other. But this says GCA, ATC, TTC, CT became G. This is a deletion, okay? In the reference, there is more than in the variance, okay? But let's count this up, okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that's 10. Good. This is coming in here, allele fraction 1, 200 reads, and it looks like, I have to look at it carefully, but that looks like that is not, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. This does not add up to multiples of 2, so I'd have to look closely to see, is this a frame shift? I don't know. I need to look more carefully, okay? But anyway, so let's look at some of this and go back to nextclade. When we look at nextclade, can somebody maybe translate that bit that I said about the variance into frames quickly? Just they can about this. What does these things mean on this side? Can somebody help translate?
Bon, ce qui essaie d'expliquer, c'est surtout deux informations. Quand on voit ici bien, il y a une valeur. Pour confirmer si c'est une mutation ou pas, il faut voir la valeur de AF. Il y a une valeur ici, AF. Donc ici, il y a des informations, une valeur AF. Et puis, il faut voir DF qui est le diff, la profondeur, qui veut dire combien de rites qui se sont alignés sur la référence. Alors ici, par exemple, nous avons 191, ici. Et quand on voit la valeur AF, ça veut dire quoi? C'est une valeur qui est entre 0 et 1. Quand c'est 1, ça veut dire que tous les rites comportent cette information A. Ce que ça veut dire. Et là, ça donne quand même un confort. Mais si c'est 0, ça veut dire que quand même là, 0,1 ou combien, c'est en bas, c'est pas vraiment, c'est juste quelques rides qui contiennent l'information. Donc, si on voit bien, ici, dans la référence, c'était G, mais au niveau de nos consensus, ça devient A. Ça devient A. Et si on voit ici la profondeur diff, c'est ça on a intégré, et la valeur AF est 1. Ça veut dire quoi? Ça veut dire quoi? Ça veut dire que tous les rites qui sont alignés, ils contiennent la lettre A. Et ici, il est revenu ici. Vous voyez ici, on est à... Donc ici, c'est environ 11 nucléotides. Et ici, c'est Jean. C'est juste un seul. Et lui, il disait que ça peut être une direction, mais il doit confirmer par après à votre analyse. Et si on voit bien ici, combien de rites?
One down. I need to move sideways. Yeah, there.
Combien de rites? Hein?
It's this one. You're on the wrong row. It's this one.
C'est 244. Et la valeur de AF, c'est combien? Ça veut dire quoi? Ça veut dire que les 200, ils contiennent, ouais, mais il va confirmer ça avec la
we will look at confirming this a little bit later. Okay. Now, just to move things.
Pardon? He's asking about where the diff is beyond 100. I think it was 8. Like this,
Oui, voilà, il y a 44, ça veut dire quoi? AF est 0, 8, voilà.
Alors,
Yeah.
where's the diff?
The AF.
Yeah. 84. Et AF, c'est 0. Donc, ça veut dire qu'il y a très peu de rides qui contiennent le variable-là. Donc, ce n'est pas quand même confortable. Et c'est un peu de rides.
And what we will look at later, we are now looking at the variants. Later, we will look at the reads themselves to see what does that look like. Okay? Just one last thing before I go off this. If we take nextclade, we can move here, and we can see the substitutions. A18769G. Okay? So now, it's 186, missing this. The coordinates are not the same because the reference is not the same. So it's not easy to show here. Let me try another example. I'm just going to look for... Yeah. You do? How do we do that? Okay. You know what? But I'll show it the other way around. So we see here 14022 GT. Okay? Then when we look at our consensus, where is it gone? I'm sure that's this one here. The position is slightly different, but GT 14000 position is different because the reference here that they're using is a slightly different reference. So the position is a little bit different. You're right, Stephen, you can load your own reference into nextclade for this analysis, but I wanted to just show that what you see in the VCF, the variant, shows up in the nextclade. Broadly speaking, okay? Okay. So now, what I would like to do is for everybody to get, I don't know, my helpers, do you think that, I don't want to take too much of Stanislav's time, but I was thinking that if everybody can get VS Code installed, that's not that difficult. So can everybody get...
Can you send me the link?
Yeah.
Can you just tell me if this is the right
if you just say VS Code, and I will look for the Visual Studio Code,
This one?
download...
Just the right one.
That's correct. Put that on the WhatsApp. So can everybody download this software and install on their computer? Okay. So can we? If you've got this thing, if you've got Visual Studio Code installed, put a green sticky. If you need help, put a red sticky. Okay. Kirsty's sending you the link by WhatsApp, huh? Got VS Code installed, okay? I'm going to give the instructions for Windows, for Mac and Linux. It will be a little bit different, obviously. But for Windows, go to the dossier, the folder, where you got your results yesterday, okay? So, I put my results in a folder called mpox1 output. Go to the folder where you put your analysis results yesterday, okay? Then go to the call consensus freebase, and then right-click. Take down your sticky notes for now. Take down the sticky notes. We're moving on to the next step. Okay? Sticky notes off. And then right-click. Ouvrir avec, and if it's not in the list, you must go. If it's not already in the list, you must go. Choisir un autre app, okay, and then you look for it until you find the Visual Studio Code, okay, and then you choose it, okay, and then you open it, okay. So just. Can everybody try and open the VCF file?
Oh, sorry.
I am here doing all of the teaching.
Oh, I almost thought you were saying your last contribution to science.
My last contribution to science.
No.
Before I quit. Before I go to Canada, right? Okay. I want to go one step back. Light show. Okay. We looked at the consensus, we looked at the variance, okay, the VCF. Now let's look at the evidence. What do the reads look like, okay, when they lined up like this? Now it gets a little bit more complex. We need a tool called IGV. Okay, I'm just thinking, how am I going to present this all to people? How am I going to Kirsty? How can I distribute this genome? Before I can look at the reads, I need to know which reference did I use, okay? And So I'm going to load the genome from a file. Where's the screen is on this side. I think I put reference genomes on the flash drive. Did I?
Yes, you called this background.
Background. Okay, background.
No, you called references. You called references.
I put references. Dropbox. So here's the data that you got on the flash drive, right? And the references. Trace, Kirsty, can you make can you make a note that we need to MT9031? Okay. So I'm going to load the genome. And I can see nothing, but it shows MT903 here in the corner. Okay. Now I need to load the reads. The reads are in a format called binary alignment, BAM. Okay, like bam, bam, bam. Okay. But this, if I need to find the reads, file, load from file. It opens the window on my other screen, so I'm just going to fix this window. Oopsie, oopsie, oops. Look in documents, mpox1 output, and now I'm looking for the folder that is called align trim. Okay, align trim. Okay. You're going to need this IGV tool, but I'll show you just now how to install it. And then I'm looking for, so what have I got in the align trim folder? I have BAM and BAI, the two things that go together. BAI is the index for the BAM, okay? But I want to open the BAM file for my sample. If you have more than one sample, you will have more than one BAM file in this folder. Okay? Yeah. Maybe I should pause. Sorry, Stanislas, what are you busy doing? There. IGV. But everyone must look at IGV together. So let's just, can you paste it with me so that you can translate if needed? Okay? So I showed how to load the FASTA into IGV from load genome, load file. Now I'm loading the BAM file. Okay. And now it says zoom in to see alignments. Okay, because it's look at the positions. 20, 40, 60, 80, 100, 120, 140, 160, 180, basically 200, okay? This is the size of one mpox virus genome. I'm just waiting for people to catch up. Just to catch up here. So this is, you're seeing one genome here. But what we want to look at? Let's look at an area that is interesting, where there is a variant. Okay, so let's go back to, I'm going to look at the VCF. Let's look at, for instance, position 12849, because it says there's a variant here, TC, 12849, okay? So here at the top, you see there's the name of the sequence, the name of the reference, colon, and the position. So I'm going to delete this. And I'm going to type 12849, which is where my variant was. Okay? And what it shows here is that the AF, it seems to be wrong in this file, because look at, oh, this was my 12849, this is this one. The depth, DP 160, this is 12849. If I move the mouse here, position 12849, okay? And it's interesting because the numbers here don't match the VCF. I'm going to ask why the numbers don't match the VCF from the authors. But we see here that this is showing C's and T's. The reference, this is the reference down here. Reference, if we go back to the VCF, oops. I just scroll sideways there. It's saying the mutation is from a T to a C. Okay? And here, where we see nothing, where it's just gray, agree, that means that the read matches the reference. Okay? So here, if I look at this position here, what is the letter in the reads at this position? What letter is expected to be here? No? Here, at this position. A. Okay? And if I went to the top of the screen, top here, above the A, then it says here, A, 165, 100% A. Okay? All of the reads are showing that. But here they are showing, some of them are showing C. And if we go down, we see, I don't know why we're only seeing a few that are like showing the C, but it's showing that the 60% of the reads here are 38% to the, 63%. I'm contradicting myself. 100 of the reads are showing C, okay? So if we scroll down, we should see more. I don't know why I'm only seeing a few in this view. Hang on. Scroll down, huh? There's, you see there, C, 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 okay? So, but let me take another position from the VCF. You see the quality is 989. It's a little bit high, but not very high. So let's look at this one, C to T at position 7793. Look at this. 7793. Remember the quality for this variant, 6492. It's very high, okay? And look at here. It's almost all red, okay? So, the reference is a C, but it is a T, 200 reads, 100%. Okay? That's why the quality is so high. So for sure, we accept this variant. I need to go back to the authors and ask why the other variant was included, because it was only 63%. I'm going to find out why that is. But now, one last thing before I get you to do this yourself. Let's go to 133188.
Can maybe translate this.
Yeah, okay. Do you want to maybe translate what I was showing with? Let me go back to the other variant that I was showing. Just to translate. 779. Okay, can you just explain what I was showing on contact? How the reads are showing the evidence for this variant.
Regardons cette position. À cette position, normalement, sur notre génome de référence, c'est un C. Quand on regarde ici, ce qui est inclus ici, ce sont les reads qui sont alignés sur notre génome de référence. Et donc, si on regarde principalement sur tous les reads, qu'est-ce qui apparaît? C'est un T qui est devenu, le C est devenu un T.
And then you can see from the color of this block at the top. Okay.
Ça veut dire que si c'est avec confidence, ça veut dire que c'est bien, le quai est bien numéro, ainsi. Ici est passé.
Okay, and then I wanted to show the next one, which was this more complex one here. Oops. I put this, sorry. Oh, oops. Let's try again.
133, 188.
What I'm showing here, this is the depth of it. So this column here, this row here, this is the depth. How many reads are deep here? You see it goes to nothing here. It goes drops. And then we get this. 10 is missing. In the reads, there's no reads here. Okay? Why? Because this virus has mutated and those nucleotides have been deleted. They're gone. So, and what's interesting to me is the number 10. Why 10? Normally, I would expect 9, 6, 12, because I would expect to see a codon disappear. 3 disappears, or 6 disappears. So that means that, that means that 10 disappears, which means that this actually means that if this is in, let's say that the codons, let's imagine that this is, that the codons are here, CGG, CAA, codon 1, codon 2, codon 3, codon 4, and then there's half of a codon is missing, or two-thirds. Which I'm surprised by this. This is a frame shift mutation, but there's strong evidence that it's real. Okay, so if we look to see which gene is impacted by this mutation, then that would be interesting because some protein will not be made right? But anyway, so this is a deletion. If you saw an insertion, you'd see another character, but this is a deletion, and you can see the depth. And one last thing I want to show here. Yeah.
So how do you differentiate between a true deletion and inability for us to sequence?
Inability to sequence, yeah. That's a good point. Because the other thing is why? Could it be a deletion? Or could it be that the sequence doesn't map here? Okay? Now, that's a damn good question because I didn't even think about it. Remember there are repeats. There are repetitive regions in the genome, okay? So let's take this CAA, TC, TT, CC. Let's imagine that somewhere else in the genome, there is also CAA, TCC. There's something that looks exactly the same. The read that should have, the read was mapped to the wrong position, and it is maybe that. There can be other reasons. It could be a. So how do you differentiate? So with difficulty. What I would look at here is when so I haven't discussed this yet, but the tool Squirrel identifies the regions that you should not use in your analysis because of that. So if it's a region that Squirrel identifies as we should ignore, then that would be, then I'd say they don't ignore it. But if it's outside of the region, I'd say that we have to do it.
Yeah, because I'm just thinking about this different time. When the teacher was speaking that maybe clear was
yeah, but look, we have reads either side. Right? This is one read. Right? So this is not. I hear what you're saying. What you're talking about, Stephen, is this. What you are talking about is this. Hi, I'm teaching at the moment. Can you maybe call in like half an hour?
Can you send me by email? Can you make a copy with just those three slides and send it to me by email?
I'm just trying to find it where this starts. There.
This one, so participants.
That's what you're talking about, Stephen.
Yeah.
Here we can see this is position. There's no data there. And if we look at that position 6,000, right? Remember, at the start of the genome, we have no data. That's this gray section over here. If you open the FASTA file, you'll see a bunch of ends there. So, but let me turn that into a question. Okay. Okay. Un question por tu. Have a look at the screen, please. Let me look at the screen. The reference of the genome says here TCA whatever, but there's very few reads. What should we say in our genome that we make out of this sample? Which letter should we put in this position? This is what the reference is showing. The reads are basically showing very little information. What letter should we put in the genome, in the consensus genome? N. Where we have no data, we mustn't put a C because we don't know if it was a C or a T. Here, where there's no data, we must put an N. Where there's no, this is low depth. Here, there's only a few reads, so we must make all of these positions in our consensus genome, we must make into N. Okay? So if we don't have the data, we must say N. And in the sample data, I want to show you something. I think it's the right. I hope that it's the right stuff. Let me just show you. File. Let me see if I can find this.
Voici ce qu'on a. Prenons la zone où il n'y a rien. Si on n'a rien, prenons par exemple ici, on ne peut pas venir dire que c'est un T. On a sur notre génome, on ne peut pas venir dire que c'est un A. Comme on n'a rien, on n'a aucun élément, aucune évidence pour dire que c'est l'un des caractères A, T, G. Donc ce qu'il nous reste à faire, c'est de quoi? Pour ne pas perdre de position, on est obligé de mettre à ces positions-là des N, si vous voulez, des caractères inconnus, donc le N. Donc quand on n'a aucune évidence, lorsqu'on fait le calling du génome consensus, les points où on n'a aucune évidence, il vaut mieux mettre N à la place. Donc c'est pour ça que vous voyez souvent, sur certaines positions, il y a beaucoup de N. C'est parce que lors de l'alignement, on n'a pas eu d'évidence que ce sont soit des A, des T ou des F. Okay. Il ne faut pas mettre ce qui est sur le génome de référence sommaire de N à la place.
Okay, and as the simple. Okay, and as the last task, I would like everybody to install IGV and look at this themselves. Okay, so. Oui. You don't need to download IGV. IGV is in your on the stuff that you extracted. Let me just show you. Show, not tell. Dropbox. Where's my copy of the stuff? PXV. No. Yeah. The dossier that you unpacked, you've got IGV already there, so you can install IGV from your computer. Just click to install. If you look at your inbox directories, okay, now I think I've confused almost everybody. That's fine. start up ITV for the first time, it will not say MT903345 there on the left. Yours says human. Other people, what does your ITV say in the left-hand drop-down? What does it say? Human. Saying like this, human, right? So that's because we are a minority. Okay? We who work with pathogens are a minority. I will go so far as to say we are an under-resourced minority, because the majority of bioinformaticians, they work on human. Okay? Pourquoi? Je ne comprends pas. Huh? Because they seem to care about this human thing. Okay? But whatever, we will ignore the human. Okay? We want to work on the viruses. Okay? So, you start off with this. Then you say, genomes, load genome from file. The deuxième option, load genome from file. Oui? Okay? Alors? Je sais pour la fichier. Now I'm going to my on my computer. It's in a different place. Just hang on. With my computer, everything is in a different place. But I'm going to go look for the mpox files. Why is it not Dropbox? Dropbox. But look for your mpox directory. Look for the dossier. No, references, okay? Can you find the references folder? Okay? Oui? And then you load MT903345. Okay? So you go to your unpacked folder with all of the mpox data. Okay? Then within it you find a dossier called references. Within that you find MT903345. Okay? You find that file. And then you open it. Okay? And then it changes like that. Okay. Is that, if you're having problems, if you write with that, put up the green sticky, or wave a green sticky at me. And if you're having any problem, which we do, file, menu, load from file.
It's on your other screen.
Oh, it's on my other screen. Thank you for that. And
Just put it on the main.
I'm going to do that. So then I go look for my analysis output. I see that some people have been busy and they did like so much mpox analysis overnight or something. No, serious. There's people with like lots of analysis they've done already. And I'm going to go in my mpox output and I'm going to find the align trim folder. Okay, align trim. Let's see what you got. The first thing that you see, you don't see anything here because it can't show the whole genome at once, but you see something has changed here. Oh gosh, huh? Are we doing okay? Just one second. Okay. Awesome. One day you won't eat too much late because je parle français. Huh? Oui? Ah, c'est bon. Okay, so let's go to a nice position to celebrate with a nice variant before coffee break. And let's go to this nice one at the top here. So let's go to, let's choose a new one we haven't looked at before. I'll type this slowly. 37224. 30 000.
37.
Exact. Hein?
37.
37 000. 37 000. 220 et parfait. Okay? My pronunciation is even worse than mine. Okay, but can you go to 37224? And then you must see what I can see. Like this. Green is good. Everybody is seeing what I'm seeing? Okay. I think nobody has any red stickies. Everybody is seeing what I'm seeing? Now, what I'm seeing here, this sample of virus was collected in 2023. This sample that I've got was collected from a patient in 2023, okay? When did the mutation in the virus, this mutation that I'm looking at on the screen, the reference that I'm looking at was collected in the year 2018, I think. Okay, let's say it's 2018. Reference was collected in 2018. My sample is in 2022. When did the mutation happen? So my sample is 2023. When did this mutation happen in the virus? Did this mutation happen in this sample? Is this mutation new to the virus that I sampled? Is this a new mutation? Or was that mutation there before and has been in other viruses in the population? Can somebody translate that question? This mutation that I'm seeing here, this G to an A, is this mutation unique? Is it new to the sample that I collected in 2023 or not? Can somebody translate that into French?
Go ahead.
I'm
going to try only to practice my French.
Okay.
Elle demande que le nouveau nucléotide A, c'est unique pour la même séquence ou asymptotique.
En fait, il dit que pour la souche de référence, il a été collecté en 2018. Mais la souche qu'il a lancée, ça a été collecté en 2023. Maintenant, pour la référence, nous avons G. Mais pour la souche nouvelle, nous avons un A qui est unique. Et maintenant, il dit que cette mutation, elle est arrivée quand?
Yeah. Yeah. When did it arrive? When was it first seen? When did it first appear in the virus? 2020, we're getting guesses. Maybe we need a lotto here. 2020, 2023. Somebody is hedging his bets. Theo is correct. We don't know unless we compare, because we know that this mutation has changed. This virus is different to the virus in 2020, in 2018. But we don't know, was there a previous virus that had the mutation in that where this mutation was first seen? So whenever we see mutations, it's always relative to a reference, okay? And that's why we always need to look into a collection. So for instance, when I look at when I look at nextclade, if I click on one of the branches here, then it tells me which mutations are first seen in this branch, okay? And that's was seen in the branch, and then all the descendants, okay? When we discuss phylogenetics, we can discuss this in more detail, but my point is, just because you see a variant doesn't mean that the variant is new. It's just a variant relative to the reference. You always have to understand this. And my second point is, share your data, please. Because we cannot do this kind of work without collecting data. Now, I know everybody must be acknowledged. They must get the benefit of sharing the data. Then that is complicated, because mostly we share our data, we get nothing back, okay? But as we only know about has this mutation been seen before if we've got other data to compare with. Okay, just going to end off back on this slide.
Did you understand what he said?
Yeah, maybe you can translate.
I think people understood what I said. Tout le monde comprend?
Tu leur as dit au fait qu'en fonction de la mutation qui est observée, le G qui est sur la séquence de référence et on a A sur l'autre séquence consensus, on ne peut pas, en regardant cette information seulement, on ne peut pas deviner quand est-ce que en fait, la mutation a eu lieu. Et surtout que nous avons des séquences, nous avons fait des séquençages, mais on ne partage pas toujours.
Okay. And just to finish off, because I'm in the way of Stanislas and coffee and all the things like that, we looked at the consensus, which is fast A. That's the final result. We went back to understand the VCF that lists the variants. And then we looked at the BAM file, which gives us the evidence for the variants to understand where's the evidence. So now we can, now we can go back and understand our results. We can see the data that supports our results. Using IGV or VS Code to look at the VCF, and then using nextclade to look at the consensus. Final month, I've shown you how to analyze one sample. If you just do the same thing, but with a directory full of samples, it will analyze all the samples, okay? So I don't think I need to show you how to do that. Le week prochain, you will break into groups of 2 and do projects together where you do data analysis together. So you'll have more experience. We're going to move away from epi2me now, and you're going to get back to it next week when you do your projects, okay? But even if you were to leave today and you go back to your country, you would be in a position to analyze the data that you sequenced, okay? But that we're not going to stop here, because we want to give you more power, more tools, more abilities, and means getting away from the graphics and getting into the command line. But we will do that after coffee, okay? Thank you so much.